first question, which is find the matrix column and what is its transpose. So from this three matrix, it's only C that have one column, which is its matrix column. So to transpose it, we just have to do like this. It is the original C, then we transpose it, we get like this. Okay, so for the B question, which is this equation, it wants the I, which is I, even the W, which is I is an identity matrix. So as we know, identity matrix is like this. So this matrix we just have to substitute it into I. So we write it back like this, and write I, take it. So like this, we just have to copy it and write back 3 times 1 times 0 times 0. So we get like this, and we write back times since we just have to times 1 times 0. We get this, and we times this row with this column. So we get 6 2 times 3 plus negative 2 times 0. So we get 6, and since like this times this row with this column. So we get 15, and same like this times this with this column. So we get this. So this side we just take it back since it has no multiply, it is a subtraction. So we got like this. So we just have to subtract all of this based on their side. So 6 minus 3 minus 2, we got 1. Negative 6 minus 9 minus 0, we get negative 15. And so it goes like this. So this is the final answer for the B. Okay, for the C question, it's given this equation. So it wants to write in X equal to D equation. So this is the part A. We just have to write it back 3, 2, 9, 7, 7, 8, 6. So for the X is Px, Py, and Pz. So we write it like this. And for the D, we just have to take this and we write it this. So for the number 2 moments, which we want to A determinant. So we just have to take the A, original A, we got. So we have to turn it like this, and we have to pick any row. So I take this row and I write it. So this is positive, negative, positive, negative, positive, negative, positive, negative, positive. So this is negative. So I write it negative. So if I choose this number, I have to hide this row and this column. So I get 7, 4, 6, 2. Same like this. If I choose this number, I have to hide this row and this column and this row. So I get like this 3. Okay, so like this. So if I calculate this, negative 2. This one I have to times it 7 times negative 2 plus minus negative 24 times 6. So I get 10. Same like this, I have to times it and minus this, the product of this. So the equation will give me like this. This is the one answer for the A determinant. So for the next question, find the Px. So to find the Px, I have firstly to find the A1 determinant. So for the A1 determinant, I have to substitute this side, the D side, into the first row. So I write this, I have to take this 11, 18, 15, and another I just have to write it back from the A. So I write it like this. So same like that, I have to choose either one of the row. So I choose this row, the first row. So 11, I had this row and I had this column, I get this. Same like this, 7, I had this row and I get this. So like 4. So I just have to do the same steps, which is I times this and minus with the product of this. So I get negative 14 and 6 steps. So I get this, negative 175. To find the Px, I have to divide A1 determinant and A determinant. So I just take the negatives 175 divided by the 5 that I get previously. So I get 5 for Px. So to find the Py, I have to find the A determinant. So I just take the original A determinant, which is 3, 2, 4, 5, 2, and this one I take from the D side. So I choose this row. So I hide this and this. So I get 18, 15. So 11, I hide this and this, I get this. Before I hide this, I get this. So 3, 18 times 52 minus 53 times 5, I get this. And same like this, I just have to times this and minus this product of this. Like this also the same. So I get negative 140. So P the Py, I have to divide this by the A determinant that I get previously. So I get 4 for the Py. So for the Pz, I have to take first the A3 determinant, which is I substitute the D in the third row. So I get like this, A3 determinant. So I choose this column, I choose this row. So 2, I hide this row and hide this column, I get this. Negative 8, I hide this, I get this. And negative 18, hide this, I get this. So negative 2, I just have to times 7 times 53 and minus 11 times 6, so I get 305. Same like this, I just have to take this 8 and times with this and minus with the product of this. Same like this. So the equation I will get negative 280. So the Pz, I have to take the negative 218 times negative 25, which is the first A determinant. So I get 8 for the Pz equation.
Good morning, class. And my question is question number 2, which is find the indicated limit, which given is x cubed with limit x approaches 2, which means we just substitute x, substitute with 2 So we can get 2 to the power of 3, which means 2 cube. So we can get the answer simply punch your calculator and you can get 8. This means,
so this limit, we know the graph for this limit is cube graph, so it becomes simply like go to the right because the limit is 1 so it means this is 2 and this is 8. So and they say limit approaches to 2, which means this line will go near, very near to 2 but can't get reach 2. So very near here, so the point here is 8. So it will go up there until to the moon maybe, but never get touched with number 2. So that's the first question. And we move to the question C. For question C, given the following function fx, if x by condition x is less than or equal to 0, and this one and with condition x larger than 0. So we go going forward to the question. This is show the limit fx limit x
approaches 0 exists. So this is a key point by studying the one-side limit, and this is a one-side limit of f as x approaches x equal to 0. So in this case, we need to divide it into 2 because we have 2 conditions. So first condition is x is less than or equal to 0. So we less than or equal to 0, which means negative side behind the 0. So we take negative 0. So we just substitute like this and we can get
the answer. We pass the calculator and we still get the answer 0 if we substitute 0 this into here. Same goes to the other condition, which is x is larger than 0. So we substitute 0 into this, then we can get 0. Okay. So by this, we can conclude that first condition and second condition is the same answer. The final result is the same, which is 0. So thus, limit fx with x approaches to 0 is 0. Then when this one is same, so we can get by say this is this. So number 2 is shows that limit dx. So now we use dx. Focus on dx, which x approaches to 0 does not exist. When we say does not exist, which is the final result that we can get is of course not the same. So we try like before, so we know that this we can substitute 0 into here because there is no unknown x like this like before. So with the final answer is only negative 1 and 1. So the final answer is not the same. Thus the conclusion is limit does not exist. So the next question is given the average cost function to produce 1 unit of gas is given us this function. So it's measured in Rm. So we need to find
the cost in Rm. Wait, limit x approaches to infinity and interpret your result. So this is actually a simple question, just like the first one we do. Just we need to understand the theory. The first theory to solve this infinity.
the infinity problem. So we take this limit, this one, we substitute all together all this together. So it becomes limit 2.2 plus 2500 over x with x approaches infinity.
As x approaches infinity, so the total cost we can get is 2.2. So by following the question, which is that us the measure in Rm, so we need to put Rm here, so it becomes 2 ringgit 20 cents per cat. That's all. Thank you.
So I'm good now. I'm going to show you how I solve question number 3 about derivative. So for the first question, this is my question. I have to find dy dx for this function. Firstly, I have to take out the power and I put it in front and I write it right. But it is power 7 and 1 is 1, this one is 6. Then I derive the one in bracket right, the derivative. Then I solve for this. Then 7 times 20. 140x power of 4 x to the power of 5 minus 1 is 6. For the question number 2, this is my question. Firstly, I write this my u prime and v prime. And then I substitute in my product rule formula u prime v plus u v prime. And then I get this. After firstly I derive u and I get 3x to the power of 2. This one and I write it back. Next I derive this and I get this. And I calculate like usual. And for this part, for this one I just use the algebra x to the power of 3 minus 1 over 2 over 2, and then I get x 5 over 2, and this is my final answer. For the next question, y x e to the power 2x and 2. Like usual, I
write it this one first so that it will not confuse me, and then I substitute in the product rule formula, and then I get this. I derive the two my v, and then after derive for x I get 1, and I write this back. I just copy it back x, and this is my v prime, and after calculate I get this 4x squared to the power of 2x to the power of 2 plus 2 to the power of 2x to the power of 2. Okay, for the last question for question 3a, I get 1 y equal to ln x over x. I got u ln x, v x, u prime, like as we know, ln x after we derive we get 1 over x, and for the v prime x I get 1. So for this question I use the quotient rule, that is b u prime minus u prime over v to the power of 2. So I just substitute this one into this formula. I get x over x equals to x 1 is to the power of 2, and I just cut this off, and I left with this answer for my last question. We move on to my B question, which is find the first and second derivative for the following function. So this is my first question, fx, this one. So for my first derivative, I apply the chain rule. I pull out the 3 power to the front, and then this one I 3 minus 1, and then I get 2, and then I derive 8x minus 4, yes. Then I get 8, after differentiate x I get 1, and negative 4 I get 0. So I calculate, and this is what I get. For the second derivative, f prime x, I take the first derivative and I derive back this one, and I use back the chain rule, and 24 I pull out the power 2 here, and this 2 minus 1 I get a 1 power, and then I derive 8x minus 4. So 24 times 2 I get 48. This one, then for the x I derive I get 1, negative 4, 0, just like this. Then 48 I times 58 I get 384. This one I just copy it back. Then I just times this and this. I get 384. I times with 8x I get 3072x minus 1536. Second question for the B. For x equal to ln 2x. So for the first derivative, 1 over 2x I times with the derivative. I differentiate the 2x, and this I get this. Then the derivative of x I get 1. Then at 2 times 1 I get 2. For 2x I just cut this and left me with x. And left me with 1 over x. Okay, for the second derivative, I take back this. The first derivative I have to calculate, and I differentiate 1 over x. I just I write in another way x to the power of negative 1. So this is I just use the power rule. I take the power and I put it in front. Negative 1 times x, negative to the power of negative 1 minus 1, and then I get negative 1 x to the power of negative 2. And this I wrote it in another way like this.
Okay, that is question number 3. C, there's a function of price, and there's a function price function 0 by 0 to x plus 300, and with x units. So must times with x 0 by 0 to x plus 300 x. That is the answer. And profit function, the formula is revenue minus total cost. Revenue function, profit, revenue function minus cost function. That is the revenue function 0. That is minus. So our answer is 0 by 0 to x. So x. Leverage of function from the cost, so we divide by x. Cost x. X minus x. So divide by x. X. Find the marginal cost. Marginal cost is from average cost and cost derived. Next. $70,000 per X. Okay, 0. So, too easy to derive. So, x bring to upside and become 70,000 x power of negative 1. So, derive. So, right? X 2 minus 1. Derive 0.4 plus 7,000. Negative 1. Right? X negative 1 minus 1. 6x minus 1 become 1. Right? 4 plus minus become minus 1,000 x 1 plus negative. And easy to remove the x values to the row. 6x divided by 4 and this 70,000 divided by x power of 2. That is the marginal cost. For C3 Roman, analyze the economic implication of if you get negative value in C marginal cost. So, the higher the quantity of product same X unit of the perfume, the cost will be decreased.
So the question 4 is the demand function for the sports shoe is given by this function P equals negative 0.1 x squared minus 0.4 x plus 1.6. So the first question is analyze the rate of change of the unit price when the quantity demand is 10,000 units. So it's given that x is measured in thousand.
Physical demand per week and P is the unit price in RM. So since x is measured in 1000, so the question is asked for 10,000 units. So we put x is equal to 10. But first we need to use first derivative for this function. So when we derive this function we get
Negative 0.2x minus 0.4. Then we substitute the, x is 10 and then we get negative 2.4. It means that it is decreasing at the rate of RM2.40 per 10,000 sports shoes, and the unit price at this level of demand is RM12.40. Next, question B. Find the level of production that will maximize the revenue. So, level production that will maximize the revenue. So, the revenue function we get from function of dx times with x. So, we get negative 0.1x cubed minus 0.4x x squared minus 10 plus 1.6x. So, we calculate the value of x which maximize. So, we find the axis of this between these numbers. So, we get two axes. So, we choose that will maximize the revenue. So, we take x equals to 1.24. So, question C is calculate the amount of decimal revenue. So, from the first revenue function, revenue function equals to negative 0.1x cubed minus 0.4x squared plus 1.6x. We substitute the value of x with 1.24 and then we will get 1.178 is equal to RM1.178,000. So, question D, prove that the revenue level is at the maximum. So, to get revenue level at maximum point, so we need to derive the revenue function for the second time. So, first, from the first derivative, so first we need to derive for the first time, we get this function. Then we derive again from this function and we get this. Second derivative of revenue function is negative 0.6x minus 0.8. So, since the value of x is negative 0.6 less than 0, so it's proven that the revenue level is at the maximum point.